Hi everyone, my name is Himer, and today we are going to code our first smart contract. What are the requirements for this lesson? Well, if you have a intermediate level of programming with C++, JavaScript, Java, or Python maybe, you will totally understand what we are going to do here. On the other hand, you need some basic knowledge of how blockchain technology works, and also you need to know how Ethereum works. In future lessons, we'll probably record some videos about blockchain technology or Ethereum, but there are plenty of videos about basics on blockchain technology, and a lot of people will explain you how it works. What I want to do here is to get your hands dirty. What does that mean? What I really mean is that I need you to start programming your first smart contract. Why? Because everybody talks about blockchain technology, but very few people actually know how to create a smart contract. So in this lesson, we are going to do something very simple, very basic. Don't worry about complicated stuff. We are going to program our first smart contract. To do it, we need this very important and very useful tool. It is called Remix, and it's a web application. I will give you the URL to go to this web page. This Remix tool is an IDE, which means that you can create your smart contracts here. You can program using a language called Solidity. You can also use Viper. Viper is related with Python programming. We are not going to do that here. We are going to focus on Solidity. So what do we need? We need some basic knowledge of this platform. The first thing we are going to do here is to create our first contract, and we are going to this part and create a new file. The first thing here is that we need to give a name to our contract. In this case will be hello world.sol, and that's it for the name. Before doing this, we are going to review some part of this tool. The first icon here will show me, or will be a file explorer. Okay, you click here, you'll see all the files and all the tests that you have for your in your computer. The second icon here will show you the compiler, and this is very important because you can code a smart contract with all this with all their compilers. So you can choose the compiler that you prefer. I will encourage you to use the last one to see the latest characteristics of this compiler. The second thing is the language. Obviously, we are gonna use Solidity here. The Ethereum virtual machine version will be the compiler default, and we are gonna keep this checked. This feature will allow us to auto-compile our contracts. The third icon will show you the tools that we need to deploy and run our transactions or to execute our smart contract. You will see some Solidity static analysis here in this icon, and you'll see some other tools that we are not gonna use at this moment. So the first thing that we need to do, we are gonna create, I'm gonna do this a lot bigger for you to understand what are we doing here. The first thing that we are gonna do here is to create our contract. To do it, we need to specify our compiler. We are gonna do it this way. Pragma Solidity and the version of our compiler, that it could be 0.6.0. This is a very important part because we need to specify our Solidity version. In this case, if we do something like this using this symbol, we say to the compiler that this contract will be compiled from this version 0.6.0 to the version 0.7. So when you have a smart contract in production, you need to remove this symbol and specify your Solidity compiler. Okay. Now, just for testing purposes, we are going to leave this symbol. The second part is to create our contract. The contract name will be Hello World. This contract is similar to a Java class, but very similar. For the purpose of our contract, we'll do something, we'll create a variable that is a string, will be a private variable, and will be name message. The second part will be to create a constructor. You don't need to specify a name, and will be a public constructor. So now we have our constructor, and we are going to create our first function. Okay, our function will be set message, and this function will allow us to assign a value to our variable message. Function message will receive a function set message will receive a value that will be a string, and we're saying that this will keep this won't be assigned to a variable in the blockchain. We can see this later. At this moment, we only need to specify the visibility of our function. This function will be public. This is also very important because when we send a function to the blockchain and the function is public, that means that everyone with access to the public blockchain Ethereum can see our contract and can see our function set message. We will specify, well, we are not returning any value here, and we will assign to our variable message our variable msg. Now we are going to create a second function that will be get message. This message is not receiving anything, but sorry, this function is not receiving anything, but will return a string variable. Why are we using memory? With blockchain, we need to specify when we are going to modify a variable that is that belongs to the blockchain, that is inside the blockchain. So when we modify the blockchain, we need to pay gas for that. If we need a temporary value to a variable, then we need to specify that this variable will be temporary. So that will be a string memory variable. We are going to return a variable message. We need a couple of more things. We need to specify the visibility of our contract will be view, and also will be a public function. This means that anyone can call our get message function. Anyone can see this means view means that no one will modify anything on the blockchain, and it will return a string variable. So now we have our value message, and this is our private variable, and let's see if it works. The first thing we need to do is to check if our contract compiles. So we need to go to this section and make sure that everything is fine. Okay, what happened is something is wrong. You'll get a message in this case because I'm not I deleted something in my contract, so everything is fine. What is this? In this case, I have some warnings, And this is because I'm using a string variable, so don't worry about this. The message here is that I'm going to consume an infinite amount of gas, and this is because nobody knows the exact size of at this moment. Nobody knows the exact size of this variable, so don't worry about this. This will be fine for now. Now we are going to deploy our contract to our simulator. Remember that we are not connected to a real blockchain. We have three environments here. We can connect to the simulator, to the JavaScript virtual machine. We can provide some connection to a blockchain. We can do this with MetaMask, and also we can have our own node or own blockchain like Ganache, etc. At this moment, we need our JavaScript virtual machine, and we have several accounts here. This is the public key of a user. In this case, this simulator is saying that we have 100 ether, we have this amount of gas limit, and we need a value in case we send some ether to the smart contract. Okay, so we only have one contract. Remember something important: if you have one file .sol, it is important to have only one contract. The first thing that we are going to do here is to deploy the contract. We are going to do this section a little bit bigger because we're going to see a few changes here. Remember, our contract is compiling and we don't have any problem with the code. So we are going to deploy, and we have a message here. With this message, we see that everything went well, and we have our smart contract deployed to our simulator. What do we have here? We have access to our public functions. In this case, I'm going to delete this. We have the function set message, and we can send a message. Hello world. We're going to say something like hello blockchain. If we ask for the value of our variable message, we have nothing here. This is the section to see the value of our variable message. Now we're going to set up the value of the variable message, and now we'll see that everything went well. When we have this green symbol here, it means that everything went fine, and we can identify here that the string hello blockchain was sent to the variable. Now if we get the value of message, now we get that the value is hello blockchain. Now we have two important things here that we need to stress. The first one is that when I sent my contract to the blockchain Ethereum, that cost me some gas. Remember that this is not free. And this is not free because this cost is a way to protect the network. If I send an infinite loop to the blockchain, then I will need an infinite amount of gas. If I try to create a denial of service attack by creating an infinite for loop inside a function, well, I have to pay for that loop. So if I try to attack the network, it will cost me some ether. Remember also that there is a gas limit, so even if I want to do it, there will be a finite amount of gas to do that attack. So there is no point on trying to attack the network by doing an infinite loop. The second thing that I want to stress here is that this variable will be modified in the blockchain. And this is very, very important because this MSG variable is a temporary variable. So that means that the blockchain is not affected. But message, the variable string message that is private, will be modified within the blockchain, and that's gonna cost me. When I do this, for instance, when I get a message, this is a call to the value of a variable within the um, within the blockchain, okay? And the value is hello blockchain. But when I send something, hello blockchain again, I'm going to delete this, and I do this set message. I sent a transaction to the network, and this has a transaction cost and an execution cost. So when I modify a variable, it will cost me some gas to do it. In summary, it will cost me some gas if I want to affect a variable that is part of the blockchain. So remember that. I think that's it for today. Remember to visit my website dappdojo.com. You can follow me on my Instagram, my Twitter as dappdojo. We'll be creating a few smart contracts to keep learning about how to code this very important part of the blockchain Ethereum. Okay, hope you guys learned something today. Subscribe to my channel. This is my first video. I hope I will improve later on. Uh, I will provide you this example it's a small contract, but for sure if you're learning and you want to learn how to code smart contracts, I hope this will be useful. So don't worry if you don't know too much about blockchain or Ethereum. You can test this within this site. Remember, get your hands dirty, and I'm sure you'll be fine. Thanks a lot. See you later, and keep learning.